infinitely many possibilities for b. So your exponential function is in the form y equals a b to the x. The transformed form of this looks like y equals a b to the, let's not call it, yeah, anyways, c x minus b plus e. So anything up here is horizontal translation. Anything here and here is vertical. And then some people will say, well, what about the b? The b is not a transformation. The b just has to be the same between functions. So like if I looked at y equals 2 to the x, and then I gave you y equals 2 to the 3x, this 2 has to be the same. It shows up nowhere in your transformations. It just has to be the same base. It's called the base of an exponential function. This one would be doubling. All that this transformation would have is a horizontal stretch by a factor of a third about the x-axis. Okay? So tomorrow we're literally just going through transformations of exponentials. Why? Because your test is transformations on it on Thursday anyway, so I figure we might as well hit something that's the exact same as what will be on the test. Okay. We're going to look at 2 to the x. The equation y equals 2 to the x. So all that's happening when you type it into your calculator is you're filling -3 in for x. So it's going to be 2 to the -3. Would be my y, which is 1/8. Then this one would be 2 to the -2, which is 1/4. The next one would be 2 to the -1, which is 1/2. Remember that negative exponent just takes whatever's there and it drops to the denominator. If it's in the denominator, you can bring it up to the numerator and make it positive. I don't think it's Thunder. I think it's Mr. Clayton. Television. And then this is 2 to the 0. What's anything to the power of 0? 1. And then this would be 2 to the 1, which is 2. This would be 2 to the 2, which is 4. 2 to the 3. 8, 2 to the 4, 16. So I'm going to make my x scale 1, which means every one of these ticks is 1. And I'm going to make my y scale 1. And I have to write this on here, or else I have to label every single one. If I just write that the scale is 1 and 1, then that tells the person marking it that you made each of those ticks be worth 1, right? If you made the y scale 2, they would each be worth 2. You don't have to label them all. So if we go to sketch this graph, we have -3 and 1/8. So that's really close to the x-axis, but not touching it. Then we have -2 and 1/4. Then we have -1 and 1/2, 0 and 1, 1 and 2, 2 and 4, 3 and 8, and then 4 and 16, but I'm not going to see it. What's going to happen when we go closer and closer, when we get more negative? Like -4 would be 1/16. -5 would be 1/32. You know? Yeah. What's going to happen?
What do you mean? It just keep getting closer.
It just keeps getting closer and closer to the x-axis, smaller and smaller and smaller. So this is actually going to run right along the x-axis. Right along the x-axis, but not touch the x-axis. Now, is this one growing or decaying as you move along the x-axis? It's growing. It's getting bigger, right? It's like super tiny, and then all of a sudden it grows really, really fast. That's what exponential growth does, right? You start off with something small, and then you get larger really fast. Another way of saying that is like bacteria. Bacteria start off with 1, and then it doubles. You get 2, then 4, then 8, then 16, then 32, then 64, then 128, and it's getting faster. Maybe it is Thunder. I don't know what's happening. Anyways, this one is doubling. Every single number doubled, correct? 1, 2, 4, 8, 16. This is just doubling. So it's exponential growth that's doubling. So what was my, oh, this is also something to note. This doesn't show up on your graph, but what's happening here is it's getting closer and closer to the x-axis, but it's not touching it. So you have a dashed line on the x-axis. This is called a horizontal asymptote. talked about asymptotes last year. You have a horizontal, because it's horizontal, asymptote, because it doesn't exist, but it makes the graph curve there. A horizontal asymptote at, what's the equation of the x-axis? Y equals 0. What's the only thing that can move that asymptote? What kind of transformation? It's not horizontal, which is what I said. What transformation can move a horizontal line? Vertical translations can move that, right? It can move it up, it can move it down. Can a vertical translation, like, can a vertical stretch a line? No. Can a reflection change that line? No. So the only thing that can move your asymptote on an exponential graph is a vertical translation. And remember, we're back to translations again. It's only vertical displacement and horizontal phase shift for sinusoidal graphs. Graphs that do the curve. So only transformation that can move an asymptote, a horizontal asymptote. Is a vertical translation. So what's the domain of this exponential? It goes like this. XER. It's going out to the left forever, and it's going out to the right forever. It's never like just stopping and curving back, right? So the domain in set notation is the set of x values such that x is an element of the reals. This is set notation because the squiggly brackets say the set of. And in interval notation, it would be negative infinity to infinity because it's an interval between those two values. Now that dashed red line, that's an asymptote. Does it actually exist on the graph, or is that where the graph cannot exist? That's where the graph cannot exist, right? So range-wise, this particular graph is just what? Greater than 0, greater than that x-axis. Can it be equal to the x-axis? No, because the graph can't go there. So the range is y such that y is greater than, not equal to, that's where the asymptote is, greater than 0, YER. That's in set notation. In interval notation, it's greater than 0. So I have to have a round bracket for 0 to infinity round bracket. Infinities are always round because they can't equal infinity. And in this case, the 0 has to be round because it can't equal 0. That's where the asymptote is. And then the asymptote we have here is a horizontal asymptote. At y equals 0. What about the intercepts? Do we have any x-intercepts in this case? No. So if it hasn't been vertically translated at all, exponential graphs will have no x-intercepts. If it gets vertically translated, you could end up with some, right? So this one has no x-intercepts. But it does have a y-intercept at 0, 1. So in our form, y equals a b to the x. The one we're looking at right now is y equals 2 to the x. What was my a if there isn't one? It's the number 1, right? So this says if b is greater than 0, b was greater than 0, b is 2, correct? If b is greater than 0, you get the shape above. This is called an increasing exponential function, or a exponential growth function. Now in your calculator, please type 2 to the power of x and y1. Or type it in. I don't have my computer with my calculator. Bless you. So type in 2 to the power of x and y1. Everyone should be doing that and not ignoring me. Then in y2, I want you to type 4 to the power of x. What happens? In y1, you have 2 to the power of x. In y2, you have 4 to the power of x. What happened? It increased what? Exponentially. True. Steeper. It's faster. It's growing faster, is it not? Because instead of doubling, I'm quadrupling now. Or, yeah, you know what I mean? Like, it's timesing it by 4. Okay, in y3, put in 10 to the power of x. What do you think is going to happen? It's going to grow even faster. It'll be even closer to the y-axis, right? Because it's growing really fast. So now if my initial value was 1, and I doubled, the next one would be 2, then 4, then 6, then 8. If my initial value is 1, and it's growing exponentially by 10, my next value is 10, then 100, then 1,000, then 10,000. How much faster is that growing, right? Way faster. So actually, the larger your b value, the faster increasing your graph is going to grow. So if it's 2 to the x, it's doubling. If it's 3 to the x, it's tripling. If it's 4 to the x, it's quadrupling. If it's 10 to the x, it's 10xing. I don't know. All right. So what is the value of a on this function? It's 1, right? I could rewrite this as 1, 3 to the x. So the value of a is 1. What is the value of b? 3. So we know it's growing. This is a growth. These are all growth functions, exponential growth. Why are these all exponential growth? I have 3, then I have 4, then I have 5.25. They're all greater than 1, right? So they're all growing. People are just hungry. That's your stomach grumbling. That has to be Clay, right? Yeah. His stomach is rumbling. All right. So we want a y-intercept. When we want a y-intercept, we let x equal 0. So we're going to get y equals 1 times 3 to the 0. So remember, if the 0 is on the exponent, it only affects this one, correct? So this is going to be 1 times what? What's 3 to the power of 0? 1. Anything to the power of 0. So this one has a y-intercept at 0, 1. Remember, y-intercept should always be in a coordinate. What's the value of a for this one?
1.
1 again. What's the value of b? Is it growing faster than the previous one or not as fast? Faster, because it's quadrupling now, right? A y-intercept is going to be y equals 1 times 4 to the 0, which is 1 times 1, which is still 1. So this one has 0, 1 as well. 5.25 would be the same thing. So how did the different bases affect the function? The larger the base is, when the base is greater than 1, the faster the exponential function grows. The steeper the curve. Then we're going to flip over. We're going to go to this one next. 1/3 x. 1/3 to the power of x. So now, and to get my y, I have to do 1/3 to the negative 3. Or 1/3 to the x, not to the negative 3. That's the first. So This one's going to be 1/3 to the negative 3. What happens when I have a negative exponent? It causes this fraction to be the reciprocal, and then I get a positive, right? So I'm going to get 3/1 to the 3. So it's actually 27. If you don't know that, you can type it in your calculator as well. But negative exponents just flip the fraction. So this next one is going to be 1/3 to the negative 2, which is 3/1 to the positive 2. It's getting louder, isn't it? 9.
Banging on the wall.
So 1/3 to the negative 1 is the same as 3/1 to the positive 1, which is 3. So this one's decaying, right? Here we have 1/3 to the 0. Well, that's just 1. Then we get 1/3 to the 1, which is 1/3. 1/3 squared is 1/9. 1/3 cubed is 1/27. So it's just getting way smaller, right? And this is why radioactive, it's getting even louder. I'm going to start talking like this so that, no, just kidding. We can hear over it. So all that's happening is we're starting off with a really large value, and it is thirding. So dividing by 3 each time, basically, right? So it's decaying. So if I go to draw this one, I'm going to say x scale 1, y scale 1. So I have negative 3 and 27 is too big. Negative 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1 and 3, 0, 1. 1 and the third. And then these just get hecka close. So it's decaying because it's starting off with a really large value. Pretend that that's a nice straight line. And then it's running. And is it ever going to touch the x-axis? No, it'll get really, really close. It might be 0.000000007, but still not going to touch it. So is our asymptote different? No, our asymptote's still the same. We still have a horizontal asymptote. At y equals 0. The graph is just decaying. So my domain on this one's still going to be the same. It's still going to be XER. It's still going out forever in set notation. And an interval, negative infinity to positive infinity. Did my range change? Just the shape of the graph changed, right? But my range is still greater than 0. Not equal to, because that's where my asymptote's at. In interval, that's 0 to infinity. My asymptote is still a horizontal asymptote. I don't even know how anyone in that class can think. I think he's punking us. It's at y equals 0. No x-intercept. So did it change any of this table? No, you're right. And I'm sure you can't think due to the incessant noise that's going through the room. So when b was greater than 0, we got an increasing function, correct? When b, b is not negative here, right? B is not negative. B is between 0 and 1. Because what b is it's doubling, tripling, quadrupling, or it's halving, a thirding, an eighthing, right? So if it's a thirding or it's a halving, it's getting smaller, it's decreasing, right? So your b value, if it's between 0 and 1, this is called a decreasing exponential function, or an exponential, is it n? Decay function. So I'm going to add those other podcast reviews. You have no homework tonight other than reviewing, right? And your cumulative is when? Thursday.